Here is a review of the traveling salesman problem heuristics that we've learned about so far, with some important extras thrown in for good measure. Please add to your notes so that in the DCAT you can explain how each heuristic can be carried out, and you can also discuss the time complexity. Nearest neighbor works by starting at point A and going to the point nearest to it. We repeat this strategy until all the points have been joined to complete a tour. The time complexity of nearest neighbor is O(n) squared, or quadratic. And whilst our complexity chart has this as horrible, it is still tractable. And in the DCAT, you should note that nearest neighbor has the lowest time complexity of the three heuristics that we have studied. Greedy involves calculating all of the distances between our points and then sorting these distances or edges from lowest to highest. We then join the shortest edges, checking at each step that we've not formed a cycle. We then add the edges to the tour until all the points have been connected. In general, we would expect greedy to give shorter tours compared with nearest neighbor. The catch is that greedy has a higher time complexity, O(n) squared log n, and this is because of this sorting step. Here is some important terminology. A point can be called a node or a vertex. A line between 2 points is called an edge. An odd degree vertex is a point that has an odd number of edges coming out of it. In the diagram, the pink points are all odd degree vertices because they've got either 1 or 3 edges coming out of them. A pass is a series of nodes or points that have been joined together. An Eulerian pass visits each edge once. When you see the E in Eulerian, you should be thinking the E in edge. The Hamiltonian pass visits each node once. Both these terms, Eulerian pass and Hamiltonian pass, are used when we explain how the Christophilys algorithm works. Of course, before we can carry out Christophilys, we would generate a minimal spanning tree, and here are the steps. A minimal spanning tree connects all the points without any cycles, where our goal is to have the lowest possible weight. Then we can go ahead and generate a tour using Christophilys. Note that the complexity of Christophilys is O(n) cubed. To find a Christophilys tour, we start with our minimal spanning tree and then pair up all the odd vertices, finding the shortest possible edges. Then we combine the edges of the minimal spanning tree and the edges from the previous step to form an Eulerian tour. That tour is then converted into a Hamiltonian cycle where each point is visited once. In the DCAT, you need to note that in general, we would expect Christophilys to give a shorter tour compared with nearest neighbor and greedy, but you should also note that this is not always the case. The trade-off for getting a generally shorter tour is that Christophilys does take longer than both greedy and nearest neighbor.